You felt it. That oppressive, suffocating heat that makes the air feel like a thick, hot blanket. Thermometers are breaking records, and we keep hearing a term in the news, heat dome. But what is it really? Is it just a fancy name for a heat wave? The answer is no, and the science behind these atmospheric furnaces is both fascinating and incredibly important to understand. Welcome to G Fun Facts Online, where today we're peeling back the layers of the sky to look inside one of nature's most dangerous phenomena, the heat dome. Imagine putting a giant, invisible lid on a pot of boiling water. That's essentially what a heat dome is. At its core, it's a massive area of high pressure that parks itself high up in the atmosphere. This high-pressure system acts like a cap, pushing air down towards the ground. As that air sinks, it gets compressed and heats up, just like the air in a bicycle pump. This cap then traps all the hot air underneath, preventing it from rising, cooling, and escaping. The result is a sprawling dome of intensely hot air that can linger for days or even weeks, baking everything below. So what causes this massive atmospheric lid to form and just stay there? The answer often lies with the jet stream. Think of the jet stream as a fast-flowing river of air that circles the globe. Normally, it flows in a wavy west-to-east pattern. But sometimes, these waves can become huge, slow, and even get stuck in place. When the jet stream gets stuck in a pattern that looks like the Greek letter omega, it creates what meteorologists call an omega block. This block stops the normal flow of weather systems, allowing that high-pressure system to build and lock in, forming the heat dome. Once a heat dome is in place, it starts to feed itself in a dangerous feedback loop. The high pressure suppresses cloud formation, meaning clear, sunny skies. All that uninterrupted sunshine bakes the ground, which then heats the air right above it. This newly heated air tries to rise, but it can't. The high-pressure lid pushes it right back down, compressing it and making it even hotter. It's a self-sustaining cycle of searing heat. Local conditions can make it even worse. Dry soil absorbs more of the sun's energy, pushing air temperatures higher. And in cities, the urban heat island effect from concrete and asphalt absorbing and radiating heat can turn a hot day into a life-threatening one. Now, you might be thinking, are these a new thing? Not entirely. Heat domes are a naturally occurring weather pattern. But here's the critical part. Human-induced climate change is making them more frequent, much more intense, and longer-lasting. Because we've warmed the entire planet, the air being trapped under a heat dome is already starting from a higher baseline temperature. This makes it far easier to smash previous temperature records. In fact, a study on the devastating 2021 heat dome in British Columbia concluded that the event would have been virtually impossible without climate change. Another found that particular heat dome was 34% larger and lasted 59% longer than it would have in a pre-industrial world. And the impacts are not abstract. In that 2021 event, the town of Lytton, British Columbia, recorded a staggering 49.6 degrees Celsius, or 121.3 degrees Fahrenheit, the highest temperature ever recorded in Canada. The heat dome led to hundreds of deaths, massive wildfires, and huge damage to infrastructure. We saw similar events in Russia in 2010 and South America in 2023. These aren't just uncomfortable hot spells. They are disasters that impact our health, our agriculture, our ecosystems, and our economy. Before we wrap up, let's clear up a common point of confusion. Are heat dome and heat wave the same thing? Not quite. The heat dome is the cause. It's the specific atmospheric structure, that high-pressure lid in the sky. The heat wave is the effect. It's the period of dangerously hot weather we experience on the ground. So a heat dome causes a heat wave. The science is clear. A heat dome is a powerful atmospheric phenomenon, a lid that traps and intensifies heat. And as our planet continues to warm, these events are becoming a supercharged threat. Understanding the physics behind them isn't just a fun fact. It's a critical piece of knowledge in a world where we must adapt to the impacts of a changing climate and work together to address its root causes. Thanks for tuning in to G Fun Facts Online.